Hey, what's up, ladies and gentlemen? Back again with an Uncle Lee video lesson. Today, nice, started a little bit early, sorry. I hope you were in your seat. Today we're going to talk about some problems from section A2 of the review appendix in the white pre-calculus book. So the first thing we're going to talk about today is the definition of a polynomial. What the heck is a polynomial? It's many nomials. Here's what a polynomial is. We're going to consider A, B, C, D, and E real numbers. They're real numbers. Square root of 2, 5, 8, negative 9, anything you want, real number. Except we're going to have one condition on these real numbers, and that condition is that A cannot equal 0. So the rest of these guys are going to be real numbers, and we're going to consider N right there, N, this guy right there, N, a non-negative integer. That's the key here. N, which is going to be our exponent, is a non-negative integer. 0 is non-negative. N can be 0. Keep that in mind. Yes, N could be 0. So here's our polynomial then, right here. We have ax to the n plus bx to the n minus 1. Oh, if n was 5, n minus 1 will be 4. So these are integers, non-negative. Plus cx to the n minus 2. We're going to write this polynomial in decreasing degrees. N minus 1, n minus 2. Plus dot, 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 plus dx. This is x to the implied 1 plus e x to the implied 0. And we can just leave that as a particular arbitrary constant there, e. This guy here is a polynomial. That's your definition of a polynomial. Down the road in a couple months, we're in chapter 4, we're going to talk about polynomial functions. You've talked about them a little bit in your Algebra 2 class. We're going to talk about them a whole lot in this class. But this is a polynomial expression right there. So, let's have some questions. Okay, let's see. Here are some examples. What you're going to do is tell me, are they polynomials or not? Is this a polynomial? Hey, those are all real numbers. A and n's. Oh, is this a polynomial, yay or nay? Yes, that's a polynomial. How about this guy right there? Well, it only has one term. How can it be a polynomial? It can be. It can be right there. This is a big yes. This is called a monomial, a specific type of polynomial. You've talked about binomials. You've talked about monomials. You've talked about trinomials, haven't you? Hey, will you stop texting? Seriously, put your phone up. Put your phone in the phone bag right there. Please, stop texting. Pay attention. There'll be no texting in here. Stop. Okay, all right. So yes, that is a polynomial. How about this guy right here? Doesn't even look like a polynomial. So heck now, how can it be a polynomial? That's a big N for no. That's called a rational expression. We talked about them a little bit in the prior video. We'll talk about them a whole lot later on in chapter 4 too. How about this guy right here? Looks like polynomial, feels like polynomial, smells like polynomial, but it is not a polynomial. Why? Because that guy right there, negative 2, is not non-negative. Negative 2 happens to be negative. So that is a big no for a polynomial. So you have some problems because, hey, is it a polynomial or not? It's a very good idea to get yourself acclimated to what is or is not a polynomial. Next up here, hey, let's talk about just division. Let's talk about some division. 7 divided by 3, who knows what it is? Yes, 7 divided by 3, yes, it is 7/3. 7/3. But what we want to do is we want to do the division here. 7 divided by 3. And I'm going to start with a very easy one and then end up, this is real number division, and then I'm going to end up with some algebraic division of polynomials. But we all know what 7/3 is. We learned that a long time ago. 7/3 is 2 and 1/3. Oh, 2 and 1/3. 2 and 1/3. This is really funky notation for mathematicians. Funky, funky, funky. You never imply addition. What this really means is 2 plus 1/3. And that's what 7/3 is equal to. 2 plus 1/3. How did I get that? Here's how I got it. Well, if I do the division here, this is your elementary long division. of real numbers, which can be cumbersome when you do 2-digit, 3-digit numbers. We're just dividing 1-digit numbers, pretty simple. Well, how many times does 3 go into 7? 3 times. 2 times 3 is 6. You subtract, 7 minus 6 is 1, and that's where you get the 7 divided by 3 is 2 plus 1/3. Let's name some of those guys right there. Keep in mind, this is a video. What can you do with a video? You can pause the video. So don't be afraid to pause the video. Mr. Gluba, if they need to pause the video, pause the video. But we don't need to pause the video here. But let's name some things, okay? So, when I have the division, 7 divided by 3, 7 is called the dividend. 3 is called the divisor. 2 is called the quotient. And 1 is called the remainder. So you have the dividend, the divisor, the quotient, and the remainder. And what happens, ladies and gentlemen, if the remainder is 0? That's a very nice, special property. And that gives us a definition. If the remainder is 0, then the quotient and the divisor are factors of the dividend. We'll examine that a little bit later down the road. If the remainder is 0, the quotient, divisor, both are factors of the dividend. But these are terms that you need to know. Let's do a long division of polynomials. You want to? You want to? Hey, well, what about it, Fred? You want to, Fred? All right, let's do it then, Fred. Let's do an easy one right there. Let's do this guy right here. I think this is a particular problem from the homework section. It may or may not be. It doesn't matter. Here's a nice example. You are going to be asked to do, I think, 4 of these problems in your homework. So let's start with this one. I have 3x cubed minus x squared plus x minus 2 divided by x plus 2. And what I'm looking for here, ladies and gentlemen, is I'm looking for the quotient and the remainder. Quotient and remainder. So what I'm going to do is I'm going to set it up just like I did the 7 divided by 3. I'm going to do the long division. I'm going to have the long division simple. And I'm going to tell you what, long division of polynomials is easier than long division of 2-digit or 3-digit or 4-digit numbers. Polynomial division is easy peasy. So what do I got here? It's got a mark. Okay, so what I'm going to do, this is real easy. And I'm going to keep all the cubes in a column, the squares in a column, the axes in a column, and all the constants in a column. So I'm going to ask myself a question. I'm going to look at the first term of the dividend. And the first term of the divisor, I'm going to say, hey, what times x is equal to 3x cubed? What times x is equal to... Yes, you're right. You're absolutely positively right. It's 3x squared. And I want to make sure that I'm going to leave that 3x squared in the x squared column. And I'm going to tell you, if your dividend does not have all the powers, put a 0 in there. Like 3x. If this didn't have a square, you'd put a 0x squared. Because you need a column for all the powers. Column for the constants. Column for the first powers of x. Column for the second power. Column for the third power. Dot, dot, dot. So we're going to go 3x squared because 3x squared times x is 3x. And I'm just going to do, just like I do with the algorithm that you learned in the 4th or 5th grade, whenever you learned that, or 6th. 3x squared times 2 is 6x squared. 3x squared times x is 3x cubed. What's the next process in the algorithm? The next process of the algorithm is to subtract that from the 2 terms above. So I'm going to subtract this guy right here from this. And here's where you're going to make your mistake. Here's where you make your mistake, Lucy, right here. Here's where you're going to make your mistake. Because you've got to subtract this. And you want to put what you're subtracting in parentheses. Because you're subtracting the whole thing. Okay, so I have negative x squared minus positive 6. So I have minus x squared minus 6x. It's going to be negative x squared. Well, 3x cubed minus 3x cubed is 0. What's the next process in the algorithm? The next process is, bam, drop the x down. And now you're back to asking yourself a question. You ask yourself a question right here. Got a little ahead of myself right there, didn't I? You take what times x is negative 7x squared? What times x is negative 7x squared? What time? Hey, how about negative 7x? Would you relax a little bit back there? Just relax. Calm down. Take a deep breath. Negative 7x, pause it if you have to. I chose negative 7x because negative 7x times x is negative 7x squared. But I do the complete multiplication. Negative 7x times 2 is negative 14x. And now the next process is to subtract this from this rascal. Subtract it. Be careful, careful, careful with your subtraction right there, ladies and gentlemen. Be careful with your subtracting. Here's where you're going to make your mistake, Lucy. Okay, so positive x minus negative 14. Positive minus negative is addition. So I have x plus 14x is 15x. Negative 7x squared minus negative 7x squared is 0, and that's what I wanted. Drop the negative 2 down and ask yourself a question. Ask yourself a question, ladies and gentlemen. What times x? Boys and girls and friends and neighbors. What times x is 15x? Well, that's easy. 15. 15 times x is 15x. So I'm going to multiply 15 times this whole expression. 15 times 2, ladies and gentlemen, happens to be positive 30. 15 times x is 15x. And now I want to be very careful. The next thing I do, be very careful. I'm going to subtract. Bam, bam, bam. So what do you have? Work it out. What do you have? Yes, negative 2 minus positive, negative 2 minus, yes, negative 32. And that's my remainder. So now I know the quotient and I know the remainder. Here we go. So 3x, let's go to about 150 scale so I can see it all. 3x cubed minus x squared plus x minus 2 divided by x plus 2 is equal to the quotient, which is 3x squared minus 7x plus 15 plus the remainder, negative 32, over x plus 2. Okie dokie. Nice. You may need to review this. I'm not quite sure how often you did this last year. It's not going to be super prevalent in our course, but it's nice to know. The next problem we will review is very prevalent and something that students usually have trouble with, but you have reviewed it. Well, you learned it in Algebra 1 and you learned it pretty much in Algebra 2, and you need to know how to do it in this class. And that is factors, factoring polynomials. Factoring polynomials, factoring polynomials. So what we're going to do as an example is we're going to factor this polynomial. Step 1 in factoring polynomials, ladies and gentlemen, boys and girls, and you too, Brad, is to factor out the greatest common factor. So we're going to look here, and we're going to see, first of all, is there a greatest common factor? And I think that there is. Well, certainly there's an x in every term. So let's factor an x out of that rascal. Let's factor an x out. And what else is common? What else is common? A 3? Oh, no, you silly heads, no. How about a, oh, wait a minute, 4? 4, no, darn it. How about, yeah, just a 2? And now you ask yourself a question. Hey, you can drop that negative down, you can drop that positive down right there, and where I'm asking myself a question. 2x times what is 8x cubed? Looks like that's going to be a what? 4. 2 times 4 is 8, and x times x squared is x cubed. 2 times what is 32? 16. Positive times negative is negative. X times what is x squared? That's an x. 2 times what is 30? 2 times 15. X times 1 is x, and right there is the factorization. That's the factoring out the greatest common factor. So the next thing we're going to do is factor that quadratic. You can use the reverse FOIL. I don't. If you are a factoring son of a gun and you can see the factorization of that, go ahead, do it. But I'm going to go through the process, the AC process of factoring. You need to know how to factor. If you want to go right here and you write the factorization and say, oh, I don't know that, you go ahead and do that, and that's fine, I don't mind. But I'm going to go through the process of factoring this quadratic, trinomial quadratic, using the AC method. Okay? So what I'm going to do here, I'm going to go over the AC method for factoring. quadratic polynomials. Okay, this one specifically. 4x squared minus 16x plus 15. Step one is find the a, b, and c. And you know, and we're going to need this in the next section because we're going to be talking about the quadratic formula, you need to be able to pick out all quadratics are written ax squared plus bx plus c. These are arbitrary. In this particular case, a is 4. And that's the first thing you want to do is find the a, find the b, and find the c. You will need to be able to do this when you use the quadratic formula. A is 4, b is negative 16, and c is 15. Since we're using the AC method, the next thing that we're going to do here, this is the AC method, the next thing we're going to do is, hey, we're going to find AC. So we're going to find AC, A times C. A times C is 60. 4 times 15 is 60. And now we're going to find two numbers, ladies and gentlemen, boys and girls, friends and neighbors. We're going to find two numbers, P and Q. We're going to find P and Q such that P times Q is A times C, i.e. in this case, P times Q is equal to 60. What else do we want to happen? What else we want to happen is we want P plus Q to equal B. In this case, P plus Q to equal negative 16. Oh, block it off there, don't sound good. Oh, no, like it. Oh, no, Lord. Oh, put it, cover it up. Where's my blocker? Cover it up. Okay. Here's the nice thing about this. If you can't find the P and the Q, the daggone thing is prime. And what's really nice, if A is 1, all you have to do is find the P and the Q. B can be 0. Lots of things. This is the easiest method to use. Because you go AC method and everything else falls forward. But so I want to find these two numbers, P and Q, such that P plus Q is negative 16 and P times Q is 16. If you were paying attention to the video, I covered it up. What two numbers add together in negative 16? They both have to be negative because their sum is negative, their quotient, pardon me, their product is 60, their product is positive, so they're both going to have to be negative. Negative times negative is positive. And if the sum is negative, they both have to be negative. And as soon as I say that, negative 6 and negative 10. Right there they are, ladies and gentlemen. Negative 6 and negative 10. Now what do you not finish? Now what do you do with the P and the Q? What do you do now with those P and the Q? Is you take this negative 16x and you split it up. Px, Qx, Px, Qx. You split that up, Px, Qx. That comes from negative 16. There's your P and here's your Q. I got a little smiley face there with the nose and eyeballs. Yeah, it's kind of nice. Anyway, I have 4x squared minus 6x minus 10x plus 15. This is just an extended version of this guy right here. And now what do? Now you factor by grouping. You look at these two guys right here. Why did you do that, Lee? I don't know. You look at these two guys. You just look at those two guys. Raise it up a little bit, would you? You just look at those two guys and you factor out the greatest common factor. Well, what's the greatest common factor there? Oh, yes, you're right. 2 is and x is. So 2x is the greatest common factor. And you factor it out. Well, 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Okay? So if you found the P and the Q, ladies and gentlemen, this has got to factor out of those two guys right there. It happens every time. We're not going to prove it, but it does. Prove it yourself, Holmes. So I'm going to just write the 2x minus 3 there because I know I found the P and the Q. I know the P and the Q work. And I know this 2x is the greatest common factor, factored out. So now all I need to do is find the number that I multiplied 2x minus 3 equal negative 10x plus 15. Well, easy enough. Negative 5. Negative 5 times 2x is negative 10x. Negative 5 times negative 3 is 15. So that is the factorization of this rascal right there. The AC method, Lord, have mercy. Ooh, slow your roll there a little bit. You have the opportunity, I know I went through this kind of fast. You have the opportunity to pause, rewind, pause, rewind. If you need Mr. Blue to pause and rewind it, go ahead. You can, you're in a hurry. 2 days for this section, 2 days for A2. Okay? Keep in mind what I wanted originally to factor, and that was this trinomial right here that I'll have next. So I factor out the greatest common factor, and if you want to go right to that, if you're a factoring son of a gun, you want to go right to that, you go right ahead. Okay? So what have I done? I've reviewed definition of polynomial, I reviewed polynomial division, and I reviewed polynomial factoring. That should take care of it, and you're going to have 2 days to do the problems assigned from A2. See you in a bit. Bye to you.